Alright, for today's lesson, we'll be looking at Chapter 5, Properties of Matter, specifically Chapter 5.2, How Materials Can Be Classified. Now you can find that on page 10 of your Module 2 textbook. Let's start. Now the objective of this lesson is for you to learn how to describe materials in terms of some of the physical properties such as hardness, elasticity, solubility, density, boiling point, so on and so forth. And based on all these properties, right, we will then learn about why we use certain materials to make certain items. Alright, so now the metal, right, that is used to make a material, that is used to make an object, we call it the material. Okay, so the physical properties, right, of an object depends on the materials that it is made from. Okay, so every different materials, right, has its own physical property. And if we know the property, for example, like we know that metal is very hard, very strong, then we will want to use metal to make certain items that will help us, okay, to use it properly. So some examples of physical properties are hardness, elasticity, solubility, density, boiling and melting point, electrical conductivity, as well as your thermal conductivity. So later I will explain what all these things means. So what is hardness? Now if you turn to page 11 of your textbook, you will be able to see on point number 5, hardness is basically the ability to withstand scratches. Okay, a harder material can be used to scratch a softer material. It's as simple as that. So if you take let's say your scissors, for example, alright, and if you take the scissors and you try to scratch, let's say your book, what will happen? Okay, your scissors will be able to tear through the pages of your book, right? So we say that the scissors is harder, okay, than paper. That's why it's able to scratch your paper. Okay, now second point, elasticity. So what is elasticity? Now previously we have learned about rubber band, okay, and how rubber band are elastic, right? So basically your elasticity is the ability of a material to return to its original length or shape after stretching or bending. So your rubber, like what we have mentioned before, is an elastic material. When we stretch it, it can go back to its original shape. Okay, third thing. Now the third physical property that we are looking at is this thing called the solubility. Alright, now the solubility, right, of a metal basically measures the maximum amount of substance that can be dissolved in a given solid at a given temperature. Okay, sounds like a lot to digest, but to simply explain this, solubility, right, when we say something is soluble, that means that it can dissolve in water. Alright, so if I say that substance X is not soluble, that means if I put substance X in water, it will not dissolve in water. Alright, so then when we talk about solubility, that means how much, okay, how much of that substance can dissolve in water or any liquid, a specific amount of liquid at a specific temperature. Alright, why do we need to talk about temperature? If you all realize, right, when we want to make Milo from Milo powder, usually we will use hot water, we don't use cold water. Okay, why is that so? It's because when we dissolve certain substance at a higher temperature, right, we'll be able to dissolve more of that substance. So your Milo, if I use hot water, more of the Milo powder can dissolve, then the Milo that you make, it will taste better. Okay, so you can read the example here, same example, same logic. So it says that 35 grams of salt can dissolve in 100 cm of water at room temperature, but at the same temperature, another substance, okay, copper sulfate, only 20 gram can dissolve. So I will say that salt is more soluble in water compared to copper 2 sulfate. All right. Now, next one, density. Now, the next physical property that we are looking at is your density. Density, right, basically is the mass per unit volume of a substance. All right, this is the scientific definition. For simplicity's sake, what we will understand is that a material, right, if let's say if it has a greater density than water, it will sink. Okay, if it is less than water, then it will float. If we are comparing the density of two substances, right, you can just pour them together, then we'll see whether it sink or float. If it floats, then it's less than the other substance. Alright, so that's how we actually can determine density of that material compared to another material. Okay, we measure how much mass is there in a unit volume. Alright, next. So these are some density of some materials. As you all can see, right, air is the less dense, 0.0013 grams per cm cube. So this is very is the least dense, okay, of all the substances over here. And as you all can see, of course, the most dense substance here is gold. All right, gold. So this has 19.3 grams per cm cube. Okay, so if I compare, right, you see water has a density of 1 gram per cm cube. So anything below all this aluminum, diamond, lead or gold, if I put them in water, it will sink. Okay, and all these things above, if I put them in water, it will float on the water. Alright, so this is how we make use of the reading, okay, this value of density to help us determine whether the substance float or sink in water. Next, now the next physical property that we are looking at is your melting as well as your boiling point. So now I'm already at page number 13, point number 13. So this shouldn't be anything new, okay? Previously we have already learned about melting and boiling point in 5.1 of the chapter. So the boiling point is basically the temperature which your liquid changes to gas, and then the melting point is the temperature which your solid changes into a liquid. So these 2 points, we call it the melting as well as the boiling point. Alright, so different substances, they will have different melting point, different boiling point. The most common example, of course, that you all know is going to be water. Okay, so water, this common example, you know that water will melt at 0 degree, it will also freeze at 0 degree, and then water will boil at 0 degree. But not all substances melts at 0 and boils at 100. Okay, what do I mean? So you can take a look over here, for example, alcohol. Alright, alcohol don't melt at 0, it melts at negative 117, it boils at 78 degrees. Alright, and then for nitrogen, oxygen, it has an even lower melting and boiling point. It is negative. Alright, the melting and boiling point is actually negative 100 plus degrees Celsius. So that's why nitrogen and oxygen, they exist as gases at room temperature. Alright, these two substances, they are gases. Okay. Next, electrical conductivity. Now, electrical conductivity, as the name suggests, basically is a measure of the material's ability to conduct electricity. Okay, whether or not it is a good conductor of electricity or is a bad conductor of electricity. So in primary school, you should have learned already, metals are good conductors of electricity. Right, and then things like wood, plastic, they don't really conduct electricity. So we say that they are poor conductors of electricity. Next. Now, so these are some of the examples of substances as well as their electrical conductivity. Now, what about thermal conductivity then? Previously, we talked about electrical conductivity. Now we talk about thermal conductivity. The word thermal basically means heat. Okay, so thermal conductivity basically means the ability of that material to conduct heat. Is it able to transfer heat or not? Alright, so if let's say we are looking at this thing called copper. Okay, you know that copper is a metal, right? Take a look at this example over here. I have some copper rod over here. I have a wooden rod and then I have a glass rod. So this simple experiment allows us to compare the electrical conductivity of glass, wood as well as copper. Okay, so the one that will conduct heat the fastest will be able to melt the wax, okay, that is on each of these rod over here. So which one do you think will have the wax melt first? Okay, if you guess copper, then you are right. Alright, because copper will have the best thermal conductivity. Okay, this copper rod will get hot over here all the way through the fastest, so the wax will melt first. Okay, so copper is a better conductor of heat compared to glass or wood in this case. Alright, so these are some materials that's ranked in decreasing thermal conductivity. Now we are at page number 15 of your textbook, metals and non-metal. So one of the most common way, right, that we classify things is based on whether or not they are metals or non-metal. Okay, so if you take a look at the many examples in your book, all those examples on page number 15, the first few examples, silver, gold, aluminum can, copper, all those examples, these are all your metals. Okay, and if you take a look at non-metals, right, you will have wooden utensils, clothes, plastic bottle, rubber glove. Now I want you to very quickly pause the video and take a look around you. Are you able to identify things that are metallic and non-metallic in your house or your living room? Now I'm sure you are able to identify some of these items. Alright, so non-metals, right, itself, we can further classify it into different material. Okay, so these are some of the materials we can classify your non-metal into. It can be classified into ceramics, plastic, fibers, wood, and glass. Alright, so for metal over here, usually for the physical property for metal, right, usually most metal will have shiny and smooth surfaces. They are usually very hard, and most metal have very high density. Okay, so for ceramic, for plastic, for fiber, for wood, and for glass, they all have different surface texture, they have different hardness, they will have different density. Now for this, I will leave you to read. Alright, now similarly, in terms of the melting point, boiling point, metals have very high melting and boiling point. Okay, your ceramic will also have very high melting and boiling point, but for plastic, for fiber, for wood, not so much. Alright, if we heat it using a flame, we should be able to burn it. Alright, and of course in terms of the thermal conductivity as well as the electrical conductivity, metals are very good has very good thermal conductivity and has very good electrical conductivity. Whereas for your non-metals, right, they do not really conduct heat or electricity. Alright, so based on all these different properties, right, of metals, non-metal, as well as all the different physical property that we have learned, we will determine the choice of material that is used to make an item. Alright, it depends on the properties that the material have. Alright, so for example, if we want to make a pot that is used for cooking, we need to of course make sure that the pot is able to conduct heat well, so it must have good thermal conductivity. That's why you see most of the pots are made out of metal. Then for the handles of the pot, would you want your handle to be made out of a metal? Then wouldn't it be very hot for you to hold to the pot? So for handles of pots as well as pans, you'll be able to see that at the end, usually you will have a material that is made out of that has very poor thermal conductivity. Okay, things like plastic or wood. Alright. So the different properties of material, right? Once we know the different properties, we will be able to choose the best materials to make different things. Okay. So these are some examples of the different material and their properties. So for plastic, right? Plastics are actually very useful. We use it very commonly. So for plastic, we use plastic bag because it has very low density, it's very light, it's very elastic, it's very strong. Alright, then for ceramic, flower pot, we use it so that because it has a very high melting point, okay, so it can be used to, it also has a very poor heat it's also a very poor heat conductor, which will help to keep the heat within the pot. Alright, so with this we have come to the end of chapter 5.2, how materials can be classified.